and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buteau, president of PCEA. The Rochester Institute of Technology in January launched its first course on printed circuit board design. Back in February, we hosted Dr. James Lee, acting chair of the Electrical and Computer Engineering Technology Department at RIT, who helped lead the new curriculum. Instruction was performed by Dr. Kirsch Mackey, an electrical engineer and head of hardware training at HaSofu in Austin, Texas. Hello, gentlemen.
Hello.
Hello.
I want to talk today about the course itself, what was taught, the students' responses, and the next steps for the program. Kirsch, for the benefit of listeners who missed our earlier podcast, could you summarize what the course covered?
Yes, so the course covered how to design a printed circuit board from scratch, specifically an Arduino Uno from scratch, as if you were a hardware design engineer, a printed circuit board designer in the industry. And we used design for manufacturing principles and also some IPC 2221 standards in order to get it from schematic to completed printed circuit board in ORCAD PCB editor, the software created by Cadence Design Systems. And that was the course.
And who was the class aimed at? Was it underclassmen or primarily upperclassmen?
Primarily classmen in their sophomore to senior years in the university level.
Now, I know that the class was taught primarily online, although students had access to a lab. What kind of feedback did you get from them? And of course, this is all happening, of course, while COVID is still going on. They may or may not have been in their dorm rooms or in their apartments, I suspect, in addition to kind of meeting up in more kind of conventional settings. Can you give me a little bit of feedback insofar as how you felt like that part of the class went?
Well, as far as them needing to be in the lab or not needing to be, it just kind of depended on how they felt most comfortable. A lot of them showed up in the lab most of the time, and about maybe 30 to 50% of them were at home, more comfortable getting things done on their own computers. So it was a nice mix, and then I really liked it. It wasn't like most of the students stayed out of the lab or anything. They enjoyed the experience.
Jim, what was your role as the class was actually taking place? So over this past semester, because it was a semester-long class, did you mostly rely on feedback from Kirsch to gauge what was happening, or did you actually go pop in at all and see for yourself?
I did not pop in at all. This is Kirsch's class. He did a great job of organizing it and executing it. I got a lot of great feedback from students. They really enjoyed both the class content as well as the atmosphere associated with the class. And so really my role was a little bit facilitator. There are some, software management, or I should say curricular management tools at RIT that it helps to be very familiar with. So I ran some of those, communicated to students from time to time. But for the most part, I was just a happy observer.
And from RIT's perspective, Jim, could you discuss the university's goals and how the class might have met them?
Sure, absolutely. So the university goals really are a couple fold, and the primary one is we really want our students, our electrical engineering and computer engineering students, to be ready to go out in the industry and be immediate contributors. And so part of that is being able to take, electrical circuitry, designs and turn them right into printed circuit board designs that are able to get manufactured both at a small scale and then, of course, at a massive scale as well. So the better prepared they are to do that, the more valuable our graduates are to the companies or to entrepreneurs who want to go out and do this on their own. So this class is really the first part of a more concentrated effort. So I would deem this class sort of as the introductory level, and Kirsch did a great job of developing that. And then he's also agreed to continue to teach this in the future, as well as developed a more advanced course in order to give students a real nice rounding and some certifications so that they are ready to go out in both the co-op perspective, which is going to be a 6 to 12 month assignment with temporary assignment with a company, or to join a company and be an immediate contributor upon graduation.
So I want to hear a little bit more about the co-op, but first I want to take a brief break to thank our sponsor, PCB West, the leading conference and exhibition for the printed circuit board and design engineering space. PCB West takes place October 4th to 7th at the Santa Clara, California Convention Center. There is a 4-day technical conference of paid and free classes and a 1-day exhibition. Learn more at pcbwest.com. So, Jim, you were saying that there are extensions to this, that this isn't just going to be a standalone course. I want to first get a sense, what feedback did you get from those who took the class and whether they intend to make a career out of design engineering?
I think it really varied depending on the student. Some students, this is kind of a curiosity to understand, what can I do in this space, and both from just a project perspective. So I want to build a more interesting drone, right? So I'd be able to can I go and design a printed circuit board and then go off to a boutique manufacturer. There are also people, and Kirsch I got some feedback. Kirsch did a really nice job on coaching some of the students who really wanted to be working in this space. And so through some of his coaching, they were able to navigate some interviews. I think one was for a co-op, and Kirsch can correct me, but I think there was also a couple for full-time employment as well. And so they are really interested in that, making their designs real. And that's really what this class and this area and this focus is all about.
So I know that when I was in college, and just, I graduated in 1990, all right, so this is a while ago, professors kind of fell into one of two categories. They either went right from grad school into teaching, or they worked in industry and then went into teaching. But they generally weren't actively working at the same time that they were teaching classes. So I'm not sure whether that's traditional for the RIT model or not. But Kirsch, it must have been great for the students to have you actually there, a working engineer developing designs on your and your regular time, right? And then being able to talk about these things in real time with your students.
That is correct. Yeah, providing the real in the trenches experience, especially in real time, is what I really enjoy being able to do. I was working as a hardware design engineer while actively teaching the students as well. I wish I could provide real world scenarios from work that aren't tightly covered under NDA or anything like that, but I could just give general experience from previous. But I only like to teach what I'm doing or have done in the industry, and then bring them the real deal in real time. So yeah, they liked it. I liked it as well.
And Jim, you talked a bit before the break about co-ops and other classes that might be offered. Can you elaborate a little bit on that, and then what the process would be to start lining up instructors, and how fast, what the timeline I guess would look like?
Excuse me. So what we would like to, what we're working towards, I should say, developing and creating really is a 4-course sequence that allows students to understand the manufacturing side of turning your designs into a usable product. So 2 of those courses are the courses that Kirsch is either has developed in the teaching, and then the advanced course that he will be developing. We also have a microelectronics course that really talks about how do you manufacture the wafers needed in order to put into the different chips that go into the printed circuit board. And then we have an automation assembly course that works with, in particular, in this case, surface mounted technology, in order to understand the robotics nature of high-speed assembly for printed circuit boards. And so we'll bundle all those together in what we're calling an option or a track, and that'll be something that students can get on their transcript. So when they are out looking for either that co-op or for that full-time position, employers are going to be able to see that they have some real expertise in this area.
Does RIT have access to microelectronics and SMT equipment on its campus?
We do. We have a very active and growing micro E department, and they have a very state-of-the-art clean room where they take on and teach all these different concepts at both the undergraduate and graduate level.
And Kirsch, I'm assuming that over the process of teaching this class, you probably learned a thing or two about what material to include and how to sharpen the focus and things like that. I guess I'll just ask, how did teaching this class remotely to college students influence how you might teach in the future?
Excellent question. So it made me aware of how important it is to maintain weekly engagement, showing up, the different kind of preparation you would do. It actually reminded me, it took me back to my teaching assistant days. It's a lot more work than I remembered, So yeah, it was nice. Also being aware of that in-class dynamic element, that especially remotely, how to engage students. So spending more time and attention on how can I improve engagement, especially through a screen or behind a microphone. Just so many elements. Lesson planning with the documentation first, and then teaching from that documentation, and how that is more effective oftentimes than like an ad hoc approach from the mind, or where PowerPoint presentations might be appropriate. So it was a nice mix. I really learned and relearned a lot.
Jim, if I remember right, you had a waiting list for this course.
We did. And that is one of the things that encouraged me to schedule the course again for this upcoming fall term. And hopefully we will be able to fill the class every term moving forward. So yeah, there's a real demand and a real interest out there.
Did everybody who manage to make it all the way through?
Kirsch, go ahead. I believe they did. But...
Oh, okay. Well, those who started and stuck with it were able to make it all the way through. We wanted them to focus on getting past the finish line, because there are mistakes and some incomplete things all the time in industry, but not finishing is not acceptable. You don't have a job. So I wanted them to just finish, and they did. So that's great.
I know that you used the OrCAD tool throughout the class. How did you kind of balance teaching good design technique with teaching just how to use the tool to your advantage when you're laying out circuits?
Wow. Right. I'm not even sure how I managed to do that. I had maybe because using the Cadence tool is second nature. I would even dare say first nature, I like to say, to me, because I've been using Allegro Design Entry HDL, the enterprise version, for 14 years. And an OrCAD I'd been using for 5 years, excuse me. And so how I managed to do this was because I've been teaching and training and documenting and posting videos since 2014 on the right ways to use OrCAD in the design flow. I went through a bunch of trial and error to see what actually hit. And I found for the right balance for a failing, but the right balance after a few years of what students like and can engage with and understand. So I can't fully explain it, but I've integrated this tool and the process all into one while explaining and opening new concepts all at the same time, and it works. So I don't know what to tell you yet.
There's nobody on the call from EMA, design automation, but I would probably be remiss if I didn't mention their efforts in helping to get this off the ground. And we've been talking about developing courses at the college level and even earlier for prospective engineers for years. It's so exciting that you managed to actually get this off the ground, that you have plans to expand it. And I know that there's some talk even of other universities and colleges kind of picking up your lead and trying to implement something similar as well. So congratulations to you both for this. I mean, especially when everything has to be done online, remotely, to pull this off, I think is a real feat.
Well, thank you very much. We are just thrilled that the initial course went so well and was so popular. We are very happy that Kirsch is involved with our effort. I don't think we could have done it without it. And we are really looking forward to developing and growing not only at RIT, but with other universities as well. So if other universities are listening or would like to reach out, I'm more than happy to share any pieces of wisdom that we've gained.
Our guests today have been Dr. Kirsch Mackey, an electrical engineer and head of hardware training at HaSofu, and Dr. Jim Lee, who is the acting chair of the Electrical and Computing Engineering Technology Department at RIT. And listeners can see Kirsch in action at PCB West. Again, that's coming to the Santa Clara Convention Center October 4th to 7th. Learn more at pcbwest.com. For PCB Chat, this is Mike Buteau. Have a nice day.